Hello everyone and welcome back. I got a MacBook Air here for a no backlight repair, A1466. We work on these a lot. So I got a A1466 here, no backlight. I'm just going to check it, see if it turns on. So actually you can see here, let me get my torch. You might be able to see. There's a user icon right there. There's a chance that there's more damage to it, but it just hasn't killed anything else. But you know, I'm going to take a guess. It's probably corrosion somewhere, and it's possible that the underside of the board doesn't look that good. So top side looks actually quite good. I don't see any liquid damage. I don't think the sensors have been triggered. So yeah, if I look here, I just took the board out. If I look here on the underside, there is corrosion. There's corrosion on the top side of the SMC. We know this works because if this component here, this one, I believe there's PB bus G3 hot. If this component wouldn't work, the machine wouldn't be turning on. So you can see there's a bit of liquid damage there, liquid damage here. These resistors probably still work. So it looks like the liquid came in like around the side by the vent, because this side is facing the vent. Actually, now that I look on the top, there's actually corrosion here as well. We're just going to take this off. This is the JTAG connector, so we're just going to take this off because it's not used for anything. So we're just going to take it off. Apart from that, let me check the fuse and see if that's functioning. Let's see. So I'm going to put my multimeter in continuity mode. And it's going to beep if it makes contact, like this. So if the fuse works, it's going to beep. And it does. 0 ohms. So that fuse is okay. This part of the circuit is probably alright. And really all it needs is, and I hope I do have one, because I'm not sure if I actually have these in stock right now. We've used quite a bit of these. So I'm going to do really quick, let's check this. Yeah, that's okay. Bit of liquid damage here. You know, it looks like it's just the chip. Yeah, so looks good. Hasn't damaged anything on this one. These need a bit of attention. And oh, there's more here. Right here, that can be cleaned off. That's fine as well, that can be cleaned off. This board after repair is going to go back into the ultrasonic. Well, it's going to go into the ultrasonic cleaner, because I'm not going to obviously let it go out like this. I'm just going to clean it roughly as well. You see here, these are oxidized. There's a bit of stuff here as well. No problem. So water went into the by the hinge in the vent. And that's basically how I got there. So we can kind of build a story on this. It's not major, but like I said, it's going to be a short one. Just a bit of a coating on the boards, no problem. But yeah, apart from that, the rest of the board, like at the bottom here, looks actually alright. Check this. I'm going to touch these up. So in most cases, people ask me, "Oh, you know, I can't read the schematic, I can't read the board view." Look, in most cases, for MacBook repairs, like let's say 60% of the time, we don't use schematics. I can tell if the resistor is okay by the values I get on the multimeter. Because here's the thing with a resistor. A resistor will, if the resistor has an issue, like all of the time pretty much, if the resistor has an issue, it's going to show open line. Or it's going to have such a high resistance, and you know, it kind of looks suspicious. But if it's around a certain number, like let's say 100 ohms, or 100K, or like 10K, or like 50, or you know, something like that, usually you know it's good. But we know it's good anyway because the MacBook is turning on in this case. but this is basically how I build an image of how it works. So right now I got the multimeter not in diode mode, it's not in diode mode, it's in resistance mode. So I can actually measure this here. So right now the resistance is 85 kilo ohms, 86, 87, you know, it's around there. So resistance is good. Let me check this one. This one again, this one has 100k. It's obviously not broken. 100k is obviously not broken. We might replace this anyway, but like this one's already falling off of this, so I'm gonna replace this anyway. So put some flux on right there. Flux helps with the cleaning as well a bit. So if you have an area that's trashed, just use some flux and then go over it with alcohol afterwards. So I just want to make sure I have. We do these specific MacBooks, we do a lot of. And these are honestly my favorites. I know these circuits inside out pretty much. There's a trash board that has a hole in it, and I can just replace these two right here. I can just replace them onto the new board, onto the board that we're repairing, and that's it. And so far we have not used a schematic, right? So no schematic used. Most of the time you won't use it, maybe 30% of the time. Most of it is visual inspection and repair and logical thinking. That's all it is. I didn't have to replace them, but I wanted to replace them for new ones. So, you know, they were a bit oxidized, one fell off the pad, so I might as well replace them. So that's pretty much done on that. So now I'm just gonna flow them a bit in place. Yeah, that's good. And then I'm going to take alcohol and brush off the flux. Boom, sorted. And just scrape this a bit. This backlight chip is going to get replaced. So I got these backlight chips. And with that, I would suggest, if you don't know the orientation, just make a mark somewhere where you can remember where the dot goes. Use some flux as well, it helps. But yeah, the backlight circuit continues on the other side of this. Boom. So you can see here there's corrosion there. The chip is destroyed. You can see there's actually pads missing completely on this. But yeah, so that's going to be replaced now. Some flux on it. And wick up the rest of the solder and the corrosion. So that looks good. So pads look good. If you're wondering about this here, these pads obviously connect, and it's gotten rid of the coating in the middle with the soldering, with the wick, with a using the wick on it. And the corrosion itself obviously made it very brittle. It's no problem, that can stay as it is. because these two do connect anyway. So with this here, you see here, dot goes top right. Some more flux. Make sure the board's nice and hot. Place it down. Line it up as best as you can. And then just solder. It's going to move into place anyway. I can see it's going to move into this corner a bit more. Yeah, there you go. So that's straightened up. All I want to do now is a bit of flux. Flow it nicely now. And then just do this, clean it up. So that's good. Now we're going to test it. As you can see, the backlight is back on, so the circuit is fully working, as well as the MacBook in general is also fully working. If you need a repair like this, no problem. We take national mail-in UK. So if you're in the UK, you can send your MacBook over to us, or your iPhone or your iPad or any other micro soldering that we do, and we can get that sorted for you. Just go to the description. There's the website link. You can just send us an inquiry and we can get that sorted for you. If you enjoyed this video, hit the like button and subscribe. See you in the next one.